In this module, you will learn about the Earth's revolution around the Sun. Every year, we all eagerly wait for our birthdays. But have you ever thought about why a year has to be so long? Why do we have to wait for 365 days until our next birthday comes along? A year is 365 days long, because that's about how long it takes for the Earth to complete one full revolution around the Sun. Let's understand what this means. You already know that the Earth is not stationary. It rotates or spins around its own axis. As it spins, it also moves in another way. It revolves around the Sun in an elliptical orbit. One full revolution around the Sun takes exactly 365 and a quarter days. For the sake of convenience, we ignore the quarter day, which is 6 hours, and think of a year as having 365 days. Over 4 years, the remaining 6 hours add up to 24 hours, or one full day. This day is added to the calendar every 4 years. This is why every 4th year is a leap year. So much for the number of days. But what about the seasons on our planet Earth? Does revolution affect the seasons too? It does, indeed. If you look carefully, the Earth is inclined in the same direction throughout its orbit. This tilt and the revolution is the reason that we have different seasons in different parts of the Earth. Let's see how that happens. On June 21st, the position of the Earth as seen here. Try and identify the areas that receive most of the sunlight due to the tilt. As you can see, the North Pole is tilted towards the Sun. You will recognize this area as the Tropic of Cancer. This area receives direct sunlight, and as a result, it is summer in the Northern Hemisphere. This position of the Earth is called the Summer Solstice. Sunlight on these areas is at its maximum during this time of the year, and hence we have longer days and shorter nights. In fact, the areas beyond the Arctic Circle have daylight for 6 months at a stretch. The reverse happens in the Southern Hemisphere. With less sunlight, the days are shorter and the nights are longer. Now let's follow the Earth's orbit. The Earth seems to have reached another turning point. The date is December 22nd. This is when the Earth reaches the other end of its orbit. The North Pole is facing away from the Sun. This position of the Earth is known as the winter solstice. This time, the South Pole is tilted towards the Sun. This area is the Tropic of Capricorn, which receives direct sunlight, and hence it's summer in the Southern Hemisphere. As you can guess, the Northern Hemisphere has less sunlight during this time. During its orbit, there are times when neither of the Earth's poles is inclined towards the Sun. Thus, on 2 occasions, March 21st and September 23rd. Sunlight falls directly on the equator. This position of the Earth is called an equinox. On these days, the day and night are of equal duration on Earth. On September 23rd, it is autumn season in the Northern Hemisphere and spring in the Southern Hemisphere. The opposite is the case on March 21st, when it is spring in the Northern Hemisphere and autumn in the Southern Hemisphere. In this module, you learned that the Earth takes 1 year, or about 365 days, to revolve once around the Sun. The Earth rotates on its own axis. The Earth revolves around the Sun in an elliptical orbit. A full revolution takes 365 1/4 days. A leap year comes every 4 years. The extra day in a leap year is formed by adding up the quarter days, or 6 hours, over 4 years. The Earth's axis is inclined at an angle of 23½ degrees to the vertical. The Earth's tilt and revolution cause the change of seasons. The Northern Hemisphere receives sunlight for the longest duration on June 21st. This position of the Earth is called the Summer Solstice. In summer, the days are longer and the nights shorter. Daylight can last for up to 6 months in the Arctic region during the summer. The Northern Hemisphere receives sunlight for the shortest duration on December 22nd. This position of the Earth is called the winter solstice. The equator receives direct sunlight on March 21st and September 23rd, resulting in day and night of equal durations. This phenomenon is known as an equinox.